Now, if you want to, you could actually comment out all of this stuff that queries the keyboard and the mouse, because you may not want the user to mess with it. But it's just as easy to not touch the keyboard while the AI is running. And hey, it's kind of fun and cheeky to mess with the keyboard while the AI is running. That basically allows you to lean over and kick that headless dog, right? So why not just leave the code so you can kick the headless dog? It makes you feel good anyway. And it's not really cruel because it's not really alive. Okay, so I'll just stick the code right here, and basically now I'm going to just do this thing. I'm going to say if you're training and pick a random double. If it's less than epsilon, do the action. So now I need to integrate a little bit with the code that I've written. So I'm going to come up here and say include rand.h. And I better have a random number generator somewhere. Do I have one anywhere? I don't think I do. Let's stick one in the controller. So here's my controller. Actually, I better include it here instead. Rand.h. And I'll say rand, what should I call it? m_rand. By the way, if you don't know, m underscore is called Hungarian notation. It's a way to keep your member variables separated from your local variables. It's not a thing you need to do. I did it because somebody told me to, and then somebody else told me it's bad practice, and now I can't make up my mind, and half the time I do it and half the time I don't. But that's why all my member variables start with m underscore. Now, because it's there, I'm going to have to initialize it and give it a seed. 1, 2, 3, 4, 5 is a great seed, isn't it? Some people like to seed their random number generators with the time of day multiplied by the process ID. I think that's a bad idea. Here's why. Chances are, the first time you code it up, it's not going to just work, right? Things are a lot easier to debug when they behave the same way every time you run it. Now, if you really want it to behave erratically, then don't seed your random number generators, but why, right? I mean, I like determinism, so always seed your random number generators. It's just a generally good practice. Well, now that I have a random number generator, I can come down here and say, change this to if m_rand dot uniform is actually the name of the method that draws a random number. And since epsilon is just 0.5, I'm just going to magic code it right there. And there, I'm one step closer to having real code. And I think I have training already in here, don't I? No? Maybe I don't. Oh, I do in the one that I posted online. I just didn't in the copy that I had in my temp folder. So, sorry about that. Yeah, that's the way it was originally, and then somebody complained, and then I fixed the C++ version. So, sorry, it's in the C++ version now. There's a member variable called bool m_training or something like that. So now we can take that thing and come down here and switch that. And should be double ampersands. Okay. Next int is actually just next, and n in this case will be what, 5, depending on how you code it up. Let's assume you're having 5 actions. But you see what I'm doing? I'm basically taking the pseudocode and I'm turning it into code. And by the time I'm done, this should be it. Because as we see here in main, it's going to call controller.update over and over and over. And every time it calls this code, it's going to do a little bit of training of the Q table. Because right here, when it applies that equation, it updates the Q table. So eventually the Q table will get really good. And eventually, whenever we exploit, which happens 95% of the time anyway, or 100% of the time if we're not training, it will run through all the candidate actions, find the best one, and do it. And when we do the best action, it'll be smart, and so now it'll balance the poll. Okay? Get high level what your job is? Okay. Now right here, do action. What does that mean? I added a comment. That is, apply the appropriate force and call model.update. So we'll probably have some code that looks something like switch action, case 0, then we'll say, how do we apply a force? Like that. Then I'll do 1 and 0, 1, 2, 3, 4. And then let's see, let's do negative 0.05, negative 0.01, no force, 0.015. Sound good? So I've arbitrarily picked to have 5 actions, do neutral, weakly to the left, strongly to the left, weakly to the right, strongly to the right. And that seems like a good action space to me. We could do 7, we could do continuous if you want. Lots of ways to do it. We'll talk about that a little bit in a minute. And then right here we'll call model.update. I think it's actually m_model, isn't it? Yeah. So now I have done that. How do we, let me point something out here. Notice I'm updating the model here. Let's go back to main. You see here in main how in the main loop it updates the model, the view, and the controller. Do you see we're going to want to get rid of that one now? What would happen if we didn't? Yeah, we don't want to be choosing every other action. We want to choose them all. So we're no longer going to have the main loop update the model because when we update the controller, it's going to update the model. That kind of throws a slight wrench into the model view controller architecture, but who cares? They're all getting updated. It's still going to work just fine. Okay, so don't update your model here if you're updating it inside of there. And then here we're going to update that Q table, and then that's the tricky part because now we have to work with a neural network. So we'll talk about working with a neural network. Is this helpful? Am I going down the right path for helping you get a grasp on what you need to do? Yeah. Where do you store the Q table? That's where I'm going next. Okay. So question. If I were coding this up, the first thing I would do is not do it with a neural network. I would do it with a plain old ordinary Q table because then I don't have to mess with the neural network and then I can see it working and then I'll do the neural network later. Do you guys follow those kinds of incremental development approaches, or do you just go for the gold and just try to code up the whole darn thing and then pray it works? The second one. I know. You know how I know? I've been teaching for a while, and that's what students always do. They follow the directions. General advice. This will help you in life. Never do that. The best students, I assign them to code up chess, and the first thing they do is they code up tic-tac-toe. Why? Because then they get tic-tac-toe working, and then they know their minimax algorithm is working, and so they know that when they apply it to chess, they don't have to look at their minimax code, they just look at the chess code. The same thing happens with this. I'm not confident it's a great idea to dive in and try all the complexity. Try to do it in pieces as much as you can, and in the long run, it usually pays off. Having said that, this particular problem is known to be challenging for Q tables. It's very hard to discretize at the right level, and so you might actually have better success with a neural network this time. So while I rebuke you for your laziness, I kind of am also giving you the insight that this may be the only time in life when it's the right answer. Okay.
That's just because the state space is so big because...
Yeah, well, it's because... So I should partly retract this because it's true. You can do this with a Q table, but it's kind of hard to know what in the state is really important. So let's ask the question, what is state? What does state even mean? Either one's fine. Just, yeah, I guess let's do this program. What is state in this program? Yeah, it's going to be the position of the cart and the angle of the pole and the momentum and the velocity of the cart and the velocity of the pole. It's basically all the values that affect it. Doesn't include price of peanut butter in China, current stock market price of Apple stock, or many other things that are real values but aren't going to affect your cart's ability to balance itself, right? So it's whatever balances itself. It's also not going to include things like the width of your screen and things that never change. Because if they never change, then what's the point in keeping track of it, right? So it's everything that's worth keeping track of that changes. Essentially, everything that you might call state is going to be inside of your model. And here's what your model knows. Cart position, cart velocity, pole angle, pole angular velocity, and applied force. Now this is something you decide, so I'm going to claim that this is your state. Those 4 values. And, well, neural networks work with continuous values, so we can basically just put those 4 things in a vector and then you're good to go. Really easy way to do that. Let's just write vector. Let's see. Let's make a vector member variable. We'll call it m underscore state. And then I'll return a vector reference called get state. And I'll just do something like m underscore state 0 equals cart position. M underscore state 1 equals cart velocity. M underscore state 2 equals pole angle. Pretend I spelled things right. I'm not even going to compile this for you. Pole angular velocity. And how about a return m underscore state? Do you know the difference between returning a reference and returning a object by value? Okay. If you don't, read this page. And not that that one page is going to give you all of the C++ experience you need, but it does say a lot of things that confuse a lot of people with references in C++. If you're in Java, you don't have to deal with it. Good choice. Okay. Now I say good choice. I actually keep choosing C++ because it's slightly faster and I value that speed. But I have less problems from the students who code in Java, just putting that out there for experience's sake. All right. Do you see why this is going to be kind of useful? Because back here in my controller, I keep referring to this thing as I or J. So instead of let I be the current state, it's now going to look like this. Vec ampersand I equals m underscore model dot get state. And now I actually is a vector that represents the current state. And down here I say let J be the new state. I'm going to say vec ampersand J. Don't forget the ampersand. If you do, then you're actually doing a copy of the whole state space instead of a copy by reference, significantly slower. In this case, the state's only 4 double precision floating point values, not a big deal, but later in life, when you're passing around big states, you'll wish you had understood the difference between references and values. Get it. It's worth your time to get it right. So I'm going to scroll model dot get state. So now I've gotten rid of that one. Oh, there's a problem. Notice I passed it by reference here, and in my code, I stomped over this internal buffer. Subtle thing that would catch a lot of people. So I'm just going to come here and instead say vec I equals vec I for I dot copy m underscore model dot get state. How about that? Now I is its own copy and won't get stomped over when I do this J one. I just told you not to copy things by value, and I just told you to. sorry, sort it out. Okay. But you get what I'm talking about, or am I just losing you with complex minutia of the programming language? Should I do that really slowly, or are you with me? You're with me. Okay, good. Great. Okay.